Here are some pictures of capacitors. The big capacitor here you see, most probably those capacitors used in so here it says 22 to 400 volts DC. I mean, big capacitors mostly used in electrical distribution system, where to improve the power factor and some of the electrical motors. The small capacitors you see here, those are all used in electronic circuits like radio, television, or these motherboards, etc. Okay, capacitor has, I mean, as I mentioned, capacitance C indicate with C, measured in farad, but there are other units too. Other units are ampere second per volt or coulombs per volt. Coulombs per volt is a common unit too, but I'm going to use farad in this class. Symbol for capacitor. As I mentioned, capacitor store energy, and the amount of energy stored is half CV square. Let me talk about half CV square. What is half CV square? So here C indicates the capacitance value. Okay, so energy stored in capacitor is half CV square. CV square. C is the capacitance value. By the way, energy is either U or W. I think your book indicates W. It doesn't matter. You can use U or E, W, or some books uses E. It doesn't. You can use any one of those letters. Okay, measured in joule. Okay. C is the capacitance value. V is the supply voltage. V is the supply voltage. Okay. Now, another important property of capacitor is it stores energy. I mean, I have been talking about it. It stores energy, which is half CV square. We just talked about it. Another important point of capacitor is it opposes rate of change of voltage. It opposes rate of change of voltage. It indicates that so it is impossible to change the voltage across capacitor in 0 time. So it needs some time to either charge or discharge. That's what it indicates. Okay, that's very important property, very useful property in AC circuits. Okay, I'll talk about it when it comes to the AC circuit. Now, the current, I mean, as I mentioned, it stores energy in the form of electric field, right? Electric field is created by having charge on each plate. So this plate is a positive plate, is going to have amount of, negative plate is going to have amount of charge, negative Q. Q equal to CV, where C is the capacitance value, V is the voltage across capacitor. Q is the charge. Q is the charge, C is the capacitance value, V is the voltage across capacitor. That's another important formula you need to remember. We know that current I equal to dq by dt. So if I use this Q here equal to dCV by dt, C is independent of time because once you make the capacitor, that value is constant. I'll talk about it in a second. So I equal to C times dV by dt. So if the voltage does not change with respect to time, there is no current passing through it. So that indicates that in DC, capacitor is going to act like open circuit once it is fully charged. So in DC voltage is not going to change, right? So in DC, capacitor is going to act like an open circuit once it is fully energized.